Hey guys, these are your notes on the impulse momentum theorem. We're just going to derive it, and then we're going to explain all the variables in it. So deriving it starts with Newton's second law up here. I'm just going to write F equals ma for that. And it starts with a substitution. Instead of a, which is acceleration, acceleration is a change in velocity over a period of time. So we're just going to substitute change in velocity, delta v, over time, in for a. Alright, and then we have a little bit of a different looking equation, F equals m delta v over t. Now, to get the impulse momentum theorem, really all you need is one more step to change Newton's second law. You just need to multiply each side by time. Cancels on the right, shows up on top on the left, and the equation looks a whole lot nicer after that. It's Ft equals m delta v. So that basically is your impulse momentum theorem right there. Force times time equals mass times a change in velocity. Alright, so here I brought it up here. That's the theorem. Ft equals m delta v. The left side, okay, has a special name. Force times time is known as impulse. So the whole left side of that equation is called impulse. The definition of impulse, write it down, is the cause of a change in momentum. Alright, so when something gains momentum or loses momentum, the force that kind of caused that is called an impulse. Impulse is also the product of force and time. Product meaning multiplication of force and time equals impulse. The whole right side of the equation, m delta v, well, you know what m times v is. That is momentum. So m times delta v is kind of like, has to do with change now. It's change in momentum. When something changes momentum, it doesn't change mass. It usually changes speeds or velocity. So delta goes in front of the v. So the whole right side, m delta v, is called change in momentum. And we said before, impulse is the cause of a change in momentum. It's also equal to an object's change in momentum. So here we wrote down what change in momentum. It's the product of mass and the change in velocity multiplied together, right? And you could also write delta v as vf minus vi right there. Alright, so this is your impulse momentum theorem. Ft is your impulse. It's the cause of the right side, alright, which is basically the right side is your effect. So it's kind of like cause, that's the force making something see an effect. That's the way I think about it. See an effect as the change in momentum. Something's changing speed, gaining or losing momentum due to a force times a time, which is an impulse.